It's honestly kind of a miracle that digital signage on a train works at all.
Oh, absolutely.
I mean, you just think about the environment for a second. The constant vibration, the shaking.
Massive temperature swings.
Yeah.
A normal monitor would just rattle itself to death in minutes.
We really take it for granted that the screen just stays on. And that's exactly what we're digging into today.
Hmm.
We've got a stack of technical documents here for a piece of hardware called the NTI VOPEX-M12VA-8.
It sounds like a random string of letters and numbers, I know.
It does. But the deep dive here is really about the invisible engineering that keeps information flowing in these really hostile environments.
Right. On the surface, this is a VGA splitter. It takes video from a computer, sends it to multiple screens. Simple enough.
But that's not the whole story.
Not at all. If you look closer at the specs, it's a masterclass in what we call ruggedization. It's specifically designed for rail transport, mass transit, places like that.
Ruggedization. I love that term.
Mm-hmm.
So let's start with the most obvious point of failure in a vibrating environment, which has to be the plug.
Has to be.
I'm looking at the spec sheet here, and it highlights something called an M12 connector. How is that different from, the blue VGA cable I probably have in a junk drawer somewhere?
Oh, it's a night and day difference.
Mm-hmm.
Your standard VGA cable, it just relies on friction to stay plugged in.
Right, and maybe those tiny little thumb screws you can never quite get a grip on.
Exactly. But they're not structural. You trip over the cord, it pops right out.
Sure.
Now imagine that cord is on a freight train rumbling down a track for 12 hours straight. Friction just fails.
So what does the M12 do?
The M12 connector is the industrial answer to that. It's a circular, threaded connector. You don't just push it in.
You screw it in so it physically locks the connection.
It creates a sealed, completely vibration-proof bond. The documents are explicit about it. This unit is built to resist vibration. It basically eliminates the chance of a loose cable causing a screen to go black.
Okay, so we've locked the cable in. That solves one problem. But the other challenge here is distance. This unit isn't sitting right next to the screen.
No, not at all.
The specs say it can broadcast video up to 600 feet away. That's, about 183 meters from the source computer?
Which is huge. That lets you keep the delicate computer in a safe, maybe climate-controlled room while the screens are out on a freezing platform.
But I did notice a trade-off in the resolution charts.
Ah, yes, the trade-off.
It looks like a sliding scale. If you're close, say 100 feet, you get a really crisp 1920 by 1440 resolution.
High definition, yeah.
But at that max distance of 600 feet, the quality drops pretty significantly to 2024 by 768. Why does that happen?
That's just the physics of sending video over copper wire.
Yeah.
Specifically the CT5 or CT6 cables this unit uses. The further that electrical signal has to travel, the more it degrades.
It gets weaker.
It gets weaker, yeah. So this device is balancing things. It gives you extreme distance, but the cost, so to speak, is pixel density.
So if you're an engineer designing a subway station, you have to choose. Do I need this screen really far away? Or do I need it to be razor sharp?
Precisely. You fit the technology to the constraint. And speaking of constraints, we have to talk about temperature.
The operating range listed here is wild. -4 degrees Fahrenheit up to 158 degrees Fahrenheit.
That's roughly minus 20 to 70 Celsius.
Wow.
That is the real difference between commercial grade and industrial grade.
Yeah.
Your home computer would just shut off.
Right.
This unit uses a powder-coated steel chassis that acts as both a heat sink and a shield. It can sit in a rail yard in Chicago in January or a stifling factory in July, and it just keeps passing the data.
And it mentions audio support, too. Is that just a nice-to-have feature?
In transit, it's critical. It supports line-level stereo audio.
Which mean?
It means when the screen says, next stop, Central Station, the voice announcement you hear happens at the exact same time. It keeps them perfectly synced on the same line.
Ah, so you don't get that annoying lag. Okay, that makes sense. It also seems like modularity is a big theme here. It says you can chain these things.
You can. It's scalable. You add a new platform to the station, you don't need to rip everything out, you just add another remote unit to the chain. It simplifies the whole infrastructure.
So, to wrap this up for you listening, this little gray box, this NTI VOPEX unit, is basically the unsung hero of your commute.
It really is.
It's the thing that ensures you know when your train is arriving, no matter the shock, the vibration, or the weather.
It just highlights that reliability isn't an accident. It's a very specific engineering choice.
That's a great way to put it. So here's a thought to leave you with. Next time you're on a train and you see that next stop screen, ask yourself, are you impressed by the flashy digital display? Or is the real miracle the threaded metal connector that's hidden behind the wall, just holding on for dear life so the data doesn't shake loose?
A lot to think about. See you next time.